Very often, we take a look at our application and we see a shiny racing car, Ferrari, obviously red. Come on, whatever color there can be. And very often we, and here by we I mean developers, we're right. We actually took great pain to make sure that the code coverage is incredibly high. We actually have Jenkins, we have SCM, distributed SCM, number of tools verifies that our application works. We have tests. Tests say it works exactly as customer wanted it to. So everything is peachy. But racing car requires, surprise, racing infrastructure. And due to various things, for example, budget, we get something slightly different. This teeny tiny difference makes the audience go away because they cannot fit. And perhaps it resulted because all the previous applications that we delivered to our ops people were actually monster trucks. So they decided that, yeah, this will do. And then we deliver Ferrari, and pretty much the end user gets a very pleasant drive, and he doesn't care. The end user completely doesn't care whether it was the fault of the infrastructure people or whether the development people didn't tell clearly enough what they were expecting. The end user cares for his pain. So the first lesson I would like you to take home is infrastructure equals application. If you test your application, test your infrastructure. If you have expectation about performance, you cannot neglect infrastructure. You just cannot. So you need to measure it, observe it, you need to tune it. And if you have any DevOps people or ops people, do include them as a developer in the decision making as soon as possible. Now, short show of hands. Who here considers himself a developer? Okay. Now, who considers himself on the ops side, operations? Okay. And DevOps? I'm kind of trying to raise the hand. Cool. So, for ops people, you need to clamor at the developers and you need to actually strike them down each time you see them. Will I be included in the decision-making process? And after a while, the guy just will say yes to have you off his head, which will be partial success. What to teach, what to know, based from experience, because end user will not care whether it was your fault or their fault. There was a fault, and this is it. I usually speak this with Jacek. Jacek couldn't make it today, so any feedback on my Twitter or just after the conference or just after the presentation is really warmly welcome. I really want to make this presentation better, so if you have any ideas how I may do it, just let me know. You make a teddy bear. From the front, from the profile, from the back. Cute. So, what to look at? Monitoring. There is a number of tools here, and there is a saying among certain operational teams that I've met in my career, never too much monitoring. I never actually took it seriously. I thought that they were joking, but then I went to this one company and I asked what tools we have for monitoring, and one guy said, well, we have nudges. Okay, cool. Nudges is cool, it's fine. The other said, and we have Zabbix. Zabbix, I never heard the name. Oh, it's very nice for new people and my favorite tool of choice. Okay, what does it do? And we engage in a talk about Zabbix. Then the other said, well, no matter Nagios and Zabbix, we have Nimsoft. Now that's a strange name, okay, Nimsoft. I later learned that Nimsoft should be avoided like the plague. Really. Kill it when you see it. Then the developers wanted to have something to monitor their transactions and EJBs and SQL, so they introduced Java Melody. Here, Java Melody. And then the new person came to the operational team and he introduced Munion. So we had 1, 2, 3, 4, 5, and then Ganglia as a 6th tool, which was like pretty awesome. I could actually outnumber everybody. I could go to pretty much everybody on the conference and said, how many monitoring tools do you use for one application? And they would like say 3 tops. And I was like, 6. Bite the dust. Which is, of course, the only dark humor I could allow myself, because that's clearly too much. Okay, so with monitoring, you need to take care of, you need to actually look at what monitoring really does. Monitoring is not magic. There are a number of commands behind the scenes which happen, which allow you to get the data. Those commands usually come from the kernel and from the drivers. And if you happen to use really good operating systems, which gives you a number of tools, then you may benefit from it. This screenshot is taken from Brendan Gregg's blog, and it outlines a number of tools which you guys may want to use if you happen to run an GNU Linux distribution. Number of those are profilers. Some of them work only in the user space, some of them work in kernel space, some work both. However, they require one of the most engineered systems I know, which is the Solaris. You may, of course, take a look at the disks. You may take a look at memory. You may take a look at your network stack. You may take a look at how actually the syscalls are behaving, which libraries are you calling, and all that, and all that. So there is a number of tools which you may use with just a little bash knowledge. And you may get yourself a quite nifty monitoring in like a day. Monitoring, of course, means some other problems, but before I actually share with you one story about it, when you have a performance problem, very often people don't know what to do. As in, if I want to write a test, I pretty much know that I will need a given section, a when section, and the then section when the assertions will happen. But when I have a performance problem, I notice that number of quite smart people don't approach this in like any ordered manner. So this and this is called the box. The box tells you that you first need to approach a problem from the very top to the very bottom. There are other approaches, and they are equally fine, in some scenarios even more fine, but let's get you familiar with the box. First, you need to know who uses your application and how often and in which scenarios. So for example, I happened to be killed by the fact that my customer had a day where they actually offered a special promotion. If you come and use our services on this particular day, you get a free bonus. And everybody came. The only problem was that we were never informed. So all of a sudden, we got like real DDoS attack coming from various countries, and we had no clue what was going on. Obviously, one might say, you were unprepared. And yeah, you're right. We were unprepared for the fact that all of a sudden, our usual traffic can be quadrupled. We could handle double. We had plans for triple, but they killed us anyway. So, who uses your application? Another interesting story. I once worked for a company. We had a software that dealt with medical examination prior to releases of new drugs. So we sold it to French people, we sold it to German people, then we sold it to Japanese people. All seemed really nice and peachy. Things worked, and all of a sudden, we noticed that Japanese people have this really intriguing spike. Nobody else has that. But in Japan, whenever it's like 9 a.m., we have a spike, and then things are going onward. So a couple of guys from the ops team, they started to actually examining what could be the cause of the spike, and after lots of time, they finally figured out that Japan, being freaky when it comes to punctuality, had one very distinctive quality. Everybody logs in at 9 a.m. There wasn't anything to find in the code. There wasn't anything to find in the system. The machines were fine. The code was fine. But only after we learned that Japanese people have this behavior, only then we could actually know, oh, we know what this spike means. Side note, if you ever plan on working in Japan, don't ever tell that your train was late if it wasn't. Because when the train in Japan is late, when you step out of the train, there is this impeccably dressed, very handsome fellow with large stack of cards. And each card is stamped, and it says that train from A to B was late by this and that many minutes. And thus, the National Railway apologizes to your boss because they made his employee late. And if you say, my train was late, they'll say, okay, give me the card. If you don't have the card, it's kind of embarrassing. Now, when you're actually eliminated people, like this is not a traffic hour, this is not the moment where my American customers are logging in and my European customers are still working. You know that there is no special action going on, no promo day, no special event or whatsoever. Then, if you thought you go one step lower, almost right. You took a hard look at every feature that you wrote and every integration that you had to code. Because these might not be people, but other systems. Perhaps somebody coded a for loop which actually knocks at your door asking for credentials or whatever. So people and robots and pretty much everything that uses your system, your own tests, a pretty good way to die by your own tests. Been there, done that. Then you may actually step one layer lower. You take a look at the applications, you examine your data structures, you take a look at your thread pools, you take a look at how much throttling your web server can handle, and you go from the user to your application through your firewalls, network switches, and all that. So as you can see, we're now partly on an application, but partly on an infrastructure. Then you go deeper. Perhaps you have a problem because in recent upgrade, Java decided that they will actually follow the UTF standard to the letter. And all of a sudden, some classes that were quite fine to be loaded now aren't because they contain wrong UTF codes. And so on, you go down until you are on the hardware level. For those of you on the ops side, you usually go from the bottom to the top. But from the developer's point of view, it's very good to actually come from the actors. And also, I've been in the situation where I was hard-pressed and looking for a performance problem on a machine, only to learn that we actually had a new customer installed. Because there is this small problem. Hands up, who knows precisely how many users you can have in a traffic hour for your application? Okay, 2 hands up, including my own. That's rather bad. You may want to change it. No pressure, but you really may want to change it. Because your user base will grow. Your code base will grow. If you do not know how much they are growing, if you do not know, for example, introducing one user, actually acquiring a new client, how many users will this bring? Like 1 or 1,000? I had a case where I was informed that a new customer will start operation on Monday, And the only thing I neglected to ask was how many people new customer wants to set up. Because by the time I was used that pretty much every new customer meant like 500 people tops. And I had room to spare for like 3,000. Well, newsflash, they had 6,000. It was glorious day. By the end of Monday, I finally found out why my software doesn't work. And then I could only spit in my own beard because I didn't ask the damn question, because I assumed. Okay? So, knowledge versus assumptions, you need to know how many people you may expect. Very often, here you get the first manifestations of problem, but some quick thinking, simple and clever hacking, and all the various things that we developers are very proud of will make the problem manifest over here, like half a year later. And then, I bet you the best drink you can have in the city. That, first of all, you will start looking at what was changed recently. I spent once with a really smart team of smart people, like 1 week searching for an issue, and we knew it couldn't possibly be the release that we just made. But everybody else was only concerned with one fact. We have just introduced a new release. Obviously, there lies the problem. So, take a look at what you actually did and be aware of what you did in like recent period of time that matters. And I honestly cannot tell you how long that is for your application. That is up to you. Kirk Pepperdine once, during I think a Geekon conference, said that we as developers are trained to look at code. So whenever a performance problem occurs, we will, for example, search our memory and, this for loop, I never liked it. It's way too complex. Or, I know, the problem lies in this class which has 8,000 lines of code. It must be there. And cool, perhaps there is some problem there. Even better, you will find the problem there, because when you start looking for problems, you find them. So you will find the problem, then you will solve the problem, then you will proudly announce that you solved the problem, and then you will discover that you solved the wrong problem. Which is insanely cool if it happens on Friday evening. I don't wish you that, honestly. So, Java Melody is a really, really nice tool. They use round-robin database to store information. Round-robin database gives you a promise that the size will not grow, roughly speaking. Now, those of you who are actually familiar with reading documentations of tool know that, roughly speaking, may not be enough. So in case of something that stores information on your production system, roughly speaking, is not enough. You need to know. And if you cannot know, then you need to have an alerting mechanism which will tell you, well, there is a problem with whatever this tool is doing. In Java Melody's case, we actually, as developers, we wanted Java Melody to be introduced so that we could take a look at how users are traversing our application, which pages are visited more or less, the times for traversing special paths, and number of other things. In some cases, we were obliged by law, because we signed contracts where we agreed that SLA for specific path will not be higher than X seconds. So we needed to actually know how much seconds we're spending on that path. Now, it worked splendidly. Java Melody is a very good tool, easy to set up. It's one Java agent plus some configuration, and you get it all for free because it's all open source. The only slight downside, it's written by French people, and French people has this tendency that they write their code in French, which is pretty awesome if you want to learn a new language. You take a look at the comment and you read, for example, l'ordinateur l'utilisateur. Okay, Google. Now, since Java Melody worked really well and everybody liked it, the ops people liked it because we showed them how to use the tool and how they can actually take a look at the particular server and take information about its usage from Java Melody. So when they also could benefit from the tool became adopted. Cool. And we had this nifty idea. Why not make it also watch sequels? Why not make it tell us how many sequels we have which are longer than some period of time? Cool idea, everybody wanted it. Database people were happy to the point of jumping up and down. So we went for it and we killed the production. The very next day. We introduced the feature, the very next day we killed the production. Well, the only thing that saved the production was the fact that an ops person was actually taking a look at how much the logs will grow. Because despite our repeated promises that, no, it's RRD, it cannot possibly grow, he was skeptical. And his skepticism saved the day. Because he actually realized that the logs are growing on an unprecedented basis. And they were, because RRD in Java Melody works as RRD should. So first you need to actually gauge the size and then you keep it. We all of a sudden started loading a load of new data. And thus the RRD naturally expanded. We had too many sequels. So when you have monitoring tools and you like them, make sure that they are updated and that prior to update, you know what's coming. Make sure that the overhead is controlled. In Nimsoft case, just drop the tool, because you cannot do it with Nimsoft. At least I couldn't with the version I had. Now, disaster. Sooner or later, disaster strikes, and then there is one simple question. Do you have backups? Hands up, who has backups? Nice. Optimistic. This makes me optimistic. Now, hands up in the air, who ever tested his backup? Not so optimistic, but still a lot of hands in the air. Now, hands up in the air, who tested the backup, and the backup worked. Oh, come on. You're splendid. So, do not design your backups for making them and having them. Design them for restoring them. There is a couple of things here. For example, I once inquired at one company I worked for, guys, because we have this Nexus system. The Nexus is a crucial system for our development because without it, we cannot build our software on production. Every package that we use to build software comes from Nexus. Tomek, we naturally know about it. Come on, it's not our first day of work. We know about it and we use the standard company policy for backing up your crucial system. Cool, sounds awesome. What is the standard company policy? Well, that is the fact that you have one full backup and then the daily deltas. Okay, well, I guess it's better than nothing. Daily deltas means that I'll need to apply delta after delta after delta, which is kind of slow, but how long does the backup live? Well, on an average, 6 months. Everyone? No, the full one lives for 1 year. Okay, cool. Nexus is in production for 2 years. We'll call you back. Well, if they had only one full backup, which lived for a year, that meant that we now only had deltas. Restoration impossible. So, not only you need to test your backups, you need to test them regularly if you want to rely on them. Now, with backups, there is a nice primer about generally high availability systems and that by Maciej Klasek, available here. And few information. I asked you previously about it. Some time ago, like 3 years ago, when I first looked for information about it, the situation wasn't that optimistic. A number of cases did not happen, couldn't meet the downtime, data loss, couldn't meet either SLA. Now, this was the most optimistic factor. Test it regularly, everything goes to plan. almost a quarter of everybody who was asked, which was a significant improvement over situation a few years earlier, but still not enough. RPO, RTO. When you actually talk about backups with ops people, you need to make sure that you know these. If you're an ops person and you talk with developers, make sure that they know what RPO and RTO is and what it really means. Because coming from a developer side, when I first was talking about backups, I thought I understood the topic, but I had no idea. I honestly had no idea what it means. So this is a very nice metaphor. When you're driving, you take a look ahead, and the time you need to reach your objective, this is RTO, recovery time objective. Now, when you look in the mirror, you see how much distance you covered, or in case of restoring, you see how much data you lost because you weren't able to render the service. In that case, that is your RPO. Now, when you discuss backups with operating team, you need to tell them the priorities and the expected RPO, RTOs for each of the priorities. Otherwise, their backups may be totally inadequate to your needs. For example, imagine a situation when you send offsite your backup, and just as you do it, your app crashes down. Now, this means that the van needs to arrive to its destination with the backup, or you need to have a phone in the van to call them and say, "Turn around. You're our newest copy, and we're gonna use you." Replication is not a backup. Snapshot of virtual machine is not a backup, because both are heavily dependent on what you have and what is your storage underneath. If your storage crashes down, your VM snapshots may be totally unapplicable. And replication means that if you deleted the file, then replication kicks in and your backup also loses the file. Network. All of this is finite. It has limited capacity. And we, developers, very often forget that. So for example, if we had a very nice server room with incredible machines for firewall, switch, whatever, something really top-notch, this doesn't mean that we can handle a lot of data or traffic. First of all, let's take a look at the switch. So we have a switch, and the switch has really nice switching capacity and number of ports with fast Ethernet, full duplex, which means incredible amount of data passing through per second. Okay? Now, first of all, this is advertisement, okay? What you look at are data from the vendor which earns money if you buy it. Okay? Just to be clear, they want you to give them money. So obviously they write whatever is needed. In small print, most likely you will find information that to ever reach this number, you will need very special conditions in your network or in your incoming traffic. Because frankly, the switches will never perform that well unless you really take extra care. For example, which traffic do you have? Many small packages or large, fat packages, but few in number? If you have the latter, your switch loves you with a passion, and it performs. But if you are, like most of us, the usual folk, then you do not stream videos, you don't have the extra large packages coming through back and forth. You send, for example, small amount of data, like how many products this customer wants to buy. 14. This doesn't make for a large package. UDP versus TCP. Average frame size. How many packets? This actually, without knowing this, purchasing the switch is kind of purchasing it blindly. Okay, most of modern switches will handle both packages. That is absolutely true. But if you want to know whether you are in the safe zone or not, whether the advertisement on the switch parameter page is what you want, then you need to know these answers prior to buying. Now, in our server, we have, of course, Firewall, because we want to be secure. We need to be secure. Firewall has nice throughput and insanely lovely number of concurrent connections, which is number of connections that this firewall can handle simultaneously. However, it only can actually take 90,000 connections per second. Now, this, of course, also needs to be scrutinized, because also, again, this is an ad. So, we have the server room with extra large firewall. It was extra large some time ago. Similar switch and all that. We had lots of money, but limited room in the server room. So we couldn't fit in many devices. We tried to fit in devices which were large and had extra capacity. And now, we have never too much firewall because we want to be really secure. So the user passes through firewall to our servers, then tells what he wants. Servers decide that they need data from surprise database, so they go through firewall to database. Then data from database needs to actually pass through firewall to servers and then again to the user. We passed the firewall 4 damn times. This is not something that happens rarely. Okay? In number of enterprise systems, there are policies which actually regulate that database needs one extra layer of security, and the easiest you can actually deliver on that is to have one firewall act twice as a guardian. Between the world and our intranet, and between our intranet and the server with database. Okay, so you will hear that it's a standard, that ISO norms require it. This is for safety, and in all actuality, it's stupidity. Because frankly, if you want to tell me that this is defense in depth, then you need to go and read on defense in depth. Defense in depth is something that Greeks came up with so that their hoplites were covered independently. Okay, so hoplites, the guy with the spears, they actually charged the enemy, and there was one company of archers, and there was another company of archers. So when hoplites decided to retreat, archers covered them with fire. Now this was all cool because archers were independent, so if enemy general sent the cavalry and took off the archers on the right, then the archers on the left still remained. But if enemy actually, in this case, decides that, oh, I know the exploit for your firewall, then you have one firewall. That's it. So this is not really defense in depth, and you may want to consider this scenario where your demilitarized zone is covered by a different firewall. If you want a specific firewall for database, take a look at vendor solutions, or just do a simple IP tables. Should work. Sharing is caring. We want to be really good people. We want to share. You may share in your production resources between your different products. Say I have a software that recruits people, I have a software that matches people's CV to desired profiles, and I have yet another software which, I don't know, collects mushrooms because that was what first came to my mind. No, I didn't take any drugs, at least I don't know about any. So my mushroom collecting software, my matching software for CVs, and my people recruiting software will use same resources. All of them. If one of them experiences heavy traffic, this means all of them get degraded performance. Another problem is what I'll share. I'll share network, storage, because perhaps storage is an issue, because it's perhaps not cheap at your company. I worked in a company which I was told that storage is very expensive. We cannot have more storage. So we had to actually share storage between different products, which is a killer move. It earns you a lot of money spent on overtime. File system virtualization, of course, and you can also share resources between intranet and internet, between your production systems and, for example, the server which administers weekly patches for every computer in the company when it comes to antivirus definition file. If you ever had your software killed by malfunctioning antivirus, I share your pain. This was actually pretty awesome. When I learned that it was antivirus, I was totally speechless for like 2 minutes. I honestly, to God, didn't know what to say. Now, if you have internal systems in production, sharing production resources, if you have multiple products sharing same resources, you want to know what is consumed by what. You want to know which of them actually needs more or less of your resources, because otherwise, when the crash comes, you know nothing. And contacting the other team and asking them, hey, how is your product doing today? Do you have any special issues like promo day? Perhaps someone is coming to you with a DDoS attack? Because I see a spike in all my monitoring system and I honestly don't know what is going on. So, with that in mind, let's go to virtualization. So, in our lovely server room, we have storage. We have 960 drives in various tiers, which is divided by speed. We have 128 gigabytes of RAM. And we have database server, which is again a heavyweight server, because 4 CPUs, 10 cores per CPU, and hyper-threading. So I have 80 threads at my disposal. Yeah? Now, how many VMwares can I have? Question number 1 is which VMware we're talking about and whether we really trust this part. I don't. I don't recommend you to. Now, the other thing is, let's talk a bit about VMware. So it's the most popular solution for virtualization. It has a really lovely graphical user interface and allows you to click out things very quickly. I know of a number of courses which actually allow you to call yourself VMware administrator after like knowing the graphical user interface and some facts about VMware in general. And it also provides easy backup system because you can make a snapshot out of your VM and it's backed up. Obvious, right? So with that in mind, let's take a look at the situation. In virtual CPU, it's still the physical CPU underneath which really does all the work. So one of my 80 threads on my server will be busy doing the actual work. Now, if I have 160 virtual CPUs on 40 threads with hyper-threading, and vSphere, which is the administrative measurement center, tells me that my load is less than 40% and 50% of my RAM is free. That means I'm good, right? Why? I heard a no. Yes, I'm seriously over-provisioned. So how may I check it? Why actually I should not trust that data? Well, the answer lies here. What you see is high system load and low user load. The machines at pretty much any given time, 1/5 of the resources is sacrificed for something. And then something is context switching. First of all, VMware will not give you the real CPUs unless it has the full number. So, if I always said that my virtual machines will need 4 CPUs, then if I have only 2 CPUs which are free, or 3 CPUs which are free, then I will not allow them to do any work because I'll need 4. VMware only allocates the CPU to work units if it has a full number. Even if the task at hand is simple addition and 1 CPU is more than enough, we'll still wait for 4 of them. So there are cases where some of your CPUs may be busy. Now, the other thing is nothing is made of rubber, and you cannot just stretch it because you like it. If you stretch it, you will lose time on actually switching the resources. So if you have strange behavior, take a look not only at what vSphere is telling you, but also at real physical host statistics. And beware of vMotion. vMotion is, I like to call it a poor man's Robin Hood. Because if you have vMotion, then you have this really kind-hearted fellow who goes to your rich virtual machines, takes the RAM, and gives it to your poor virtual machines, which is quite awesome idea, and it's okay to have it as long as your Robin Hood doesn't start to go in cycles. Okay? So if machine A gets taken the extra RAM, and the RAM gets transferred to B, and then Robin Hood looks at B and, wow, you're filthy rich. Give back the RAM. The C needs it more. And then C, you're filthy rich again. Poor A. The bastard is actually slower. So with that in mind, you may want to take a look at how many times your vMotion actually activates. How many times it performs all those operations. Now, there are other virtualization, and I kind of will gloss over them because I'm not that well versed with them. And also, we're running out of time, so to make space for your questions. But this is actually collecting quite nice opinions from everybody I spoke with and who actually was using it. LXC is light virtualization, Linux containers. From this actually came Docker, which most likely you've heard about already. There is also KVM and OpenVZ, and other standards for virtualization. A short comparison between virtual machine and actually container. So virtual machine of the first generation requires specific layer of software to act as a supervisor between your hardware and your pretend hardware. So this layer of software acts as a go-between, and it actually is the glue that connects your virtual machine and your guest system with your host system and your real physical resources. Now, then came the second generation virtual machine, which actually used hardware, dedicated hardware, in place of just a software layer. It might be actually vice versa, but I'm not sure at the moment. We'll check and add it later to the slides. Nevertheless, very often you probably heard that containers are like virtual machines, but lighter and with smaller footprint. And on some level of generalization, that answer is okay. However, what really happens with containers is that your operating system gets cut into pieces. Some resources of your operating system are being set aside, and you access them through a specific layer called the container. And with that in mind, there are some cases where actually light virtualization, as it's called, or containerization, as it should be called, may not be your best option. It depends on what your application is actually doing. However, when you want to share libraries between all the containers, then yeah, light virtualization is much easier to achieve that. Now, a number of cases when I actually gave this presentation or talked about similar topics, I had this smart fellow or depressed fellow who actually said, ha ha ha, Tomek, it's all fine and dandy, you're talking some nice things, but I will never, ever have anything to say when it comes to my infrastructure. I'm just a software monkey. I'm delivering the code, and then my function is over. I never see the code again. I don't know what it runs on and all that. So yeah, you can be like Pilate, the guy who actually washed hands from killing Jesus, and say, not my business. I delivered the software. Okay, cool. But if you want your application to really work, you shouldn't do it. If you want your application to really be to really deliver what you wanted it and promised it will deliver, you cannot do it. So what you can do, if you are on an operating system site, on a hosting site, on a DevOps site, give your developers some access to infrastructure. Create them a read-only user, make them sign the necessary documents, and let them peruse the system without changing a thing, just so that they know what happens. Set aside Elasticsearch, Logstash, and Kibana, and feed it with logs. And allow your developers and support people and pretty much everybody else to peruse those logs and take a look at how often given exception is actually appearing within a minute from this module or from that module or generally from application. Give them tools so that they cannot say, I cannot touch infrastructure. Because if they honestly can say, I cannot touch infrastructure, they start thinking only about software. And they'll solve problems without talking to you because they cannot touch infrastructure. So they need to solve it via software, which will result in such a happy-go, merry-round cases that honestly it isn't worth it. For example, I had a person who actually called the garbage collector from Java code because he wanted to get rid of runtime out-of-memory exception. And garbage collector is what is actually being called before the exception is thrown. So totally useless gesture. But still, people who are told this line of reasoning ain't an option think in different cases, in different ways, and you will not be able to foresee it. On the other hand, if you are a developer and your ops people are like, we are the only thing that stands between the darkness and the light. If it weren't for us, your application would have eaten dust like a dozen times since I ate my breakfast. And I never eat breakfast, because breakfast is for the weak. So if your dialogues are making as much sense as this one, then you need to start talking with a corporate language, aka SLA. SLA stands for Service Level Agreement. And you may deliver a service level agreement to your ops team saying that your software will run only if the server has this and this amount of memory to be used only by your application. The RAM is in this or that configuration. The disk space is available for this and that in this and that hours and all that. Of course, this is actually drafting a contract. So my heartfelt suggestion, take those ops people to a room and iron this together. Because if you will just send it over, they'll send over something else. And you will exchange emails for the rest of your life. So, for devs people, give them access to infrastructure and have the same repository for build scripts and installation scripts. So that you will not be surprised by the fact that all of a sudden your lovely developers changed everything about how the application is built because Docker. And on the other hand, you will not be surprised by the fact that Ansible actually made your way to the all installation scripts because your people all of a sudden got real machines and they need to automate things. The era of SSH to one server, execute script, SSH to another server, execute script, finally is gone. So they have Ansible or Chef or Puppet and they can automate all of it. So no surprises on this line. Also, joint code ownership will do you loads of good. Final topic, if you measure, don't be misled by the bell curve. This problem is very nicely outlined in this presentation, which is linked here. This is so-called normal distribution. If you have normal distribution, you most likely do not do your average software. Because, for example, latency very rarely shapes up in the shape of a normal distribution, which is the bell curve. Usually, it kind of looks like that. So, if you're measuring average values, you're assuming that your values are actually in the form, they can form a bell curve, a Gaussian distribution. Make sure that is the case if you want to rely on averages. Otherwise, you may have this problem, like here. So, here we have something like percentiles, and here we have the average. So, average looks rather okay, yeah? Nothing major. Oh, here was something, then again, here was something. But 1 in 10 users will see the function of your application as totally unresponsive. So first, answer yourself this question. How badly things are going in like 1 in 10 users see my application like that? 2 in 10, 5 in 10. Then monitor for the moment when you answered, oh no, that's bad. I don't want that to happen. So use percentiles. DevOps needs to be part of the discussion since very early phases. You want to monitor as a DevOps, you want to learn your application, to know its business function. You want also for your application to be able to be monitored business-wise. Not only how green is the server, but how green is the application. So you need to talk to developers to come up with proper measures for application. You need to work together. Devs need to have access to infrastructure, so ops need to give it. Ops need to learn the application, so devs need to actually make the application learnable. They need also to have time for ops to answer the questions. Common building, common SLA, and hardware specs can be clever advertisements. Scratch averages, use percentiles. Sharing anything doesn't mean there is more of it. Thank you for your attention, and I'll gladly take questions, though it's blinking at me, probably out of time. Yeah. Thank you very much, nevertheless.